A few weeks ago, OpenAI released GPT-5, the newest version of the AI behind ChatGPT. And with it came a wave of questions. What can it do? How does it think? And how did we even get here? To answer that, we need to uncover the real story behind artificial intelligence. And that means rewinding, way back to where it all began. Our journey starts in the 1950s, a time when computers filled entire rooms and had less processing power than a modern calculator. In 1950, mathematician Alan Turing proposed a simple but revolutionary question: can machines think? He imagined a test, later called the Turing test, to see if a machine could hold a conversation indistinguishable from a human. By 1956, a group of scientists met at Dartmouth College for what would become the birth of the term artificial intelligence. They believed that teaching machines to think like humans was not only possible, but inevitable. So what exactly is AI as we know it today? Artificial intelligence is when machines are built to perform tasks that normally require human intelligence. Things like understanding language, recognizing images, making decisions, or learning from experience. Now, let's be clear, AI does not think like we do. It does not have feelings, opinions, or consciousness. It processes information, finds patterns, and makes predictions. Think of it like a master chef who has tasted every recipe on Earth and can instantly create a new dish from memory. Except instead of food, AI's ingredients are data. Here is how modern AI is made and how it works in simple steps. First, collecting data. Billions of words, images, videos, and code samples from books, websites, and public datasets are gathered. It is like giving the AI the largest library in human history and telling it to read every single page. Second, training the model. That data is fed into neural networks, which are layers of interconnected nodes loosely inspired by brain cells. These nodes adjust tiny numbers called weights multiple times until the model gets better at predicting patterns. Imagine millions of dimmer switches, all turning up or down until the light is just right. Third, tokens and predictions. AI breaks text into small chunks called tokens. Every time you type something, it predicts the most likely next token, not by knowing, but by calculating probabilities from everything it has learned. Fourth, fine-tuning and feedback. Human reviewers score AI responses, teaching it what is accurate, safe, and useful. This is often called reinforcement learning. Fifth, running the AI. When you ask a question, it runs a complex probability calculation in milliseconds, like your phone's predictive text feature, but trained on an ocean of examples. In the early years, expectations were sky-high, but reality could not keep up. Funding dried up in the 1970s in what is known for the first AI winter. There was a revival in the 1980s with expert systems, programs that followed human-crafted rules. But by the 1990s, progress stalled again, leading to a second AI winter. Everything changed in the 2000s. The internet created a tidal wave of data, enough to train AI not by strict rules, but by showing it examples and letting it learn. Suddenly, your movie recommendations, your search results, and even spam filters were powered by machine learning. The 2010s brought deep learning, neural networks with dozens or even hundreds of layers, powered by fast graphics processors. Breakthrough moments followed. AI beat champions in chess, in quiz shows, and in the complex game of Go. The combination of data, algorithms, and computation transformed what AI could do. In 2018, the FERT GPT quietly proved that large-scale language models could work. In 2019, GPT-2 generated writing so convincing that the full release was delayed out of caution. In 2020, GPT-3 went viral, writing essays, code, poetry, and more. In 2023, GPT-4 powered multimodal experiences, understanding images and text together. In 2025, GPT-5 arrived, more context-aware, more accurate, and faster. Google advanced in parallel with Gemini, and the modern AI race heated up. Think of a language model as a giant prediction engine. You give it part of a sentence, and it guesses the most likely next word, then the next, and the next. It does this so quickly and so consistently that it can feel like thinking. It is the same idea as autocomplete on your phone, multiplied by 1,000,000 and trained on far more than your texts. Today, AI quietly powers much of our world. It helps doctors detect diseases earlier by spotting subtle patterns in medical images. It protects credit cards from fraud by flagging unusual behavior in real time. It powers navigation and routing, translating languages on the fly, and keeping your inbox mostly free of spam. Before you finish breakfast, you have likely used AI a dozen times. The potential is enormous, from accelerating scientific discovery to modeling climate scenarios to building better tools for accessibility. But there are real challenges too, including misinformation, bias, safety, and the impact on jobs and education. The next chapter is not only about what AI can do, it is about how we choose to use it. GPT-5 may be the newest chapter, but it is built on decades of breakthroughs, failures, and comebacks. From Turing's question to today's neural networks, the story has been one long attempt to teach machines how to learn. Now you've got the big picture: what AI is, how it's built, and why it matters. Let me leave you with two questions. What's the one thing you hope AI will do in your lifetime? And just as important, what's the one thing you hope it will never do? Drop your thoughts in the comments. If this gave you a clearer view of AI, give it a like, share it with a friend, and subscribe, so YouTube knows to share this piece of knowledge with even more curious minds. Thanks for watching, and until next time, stay curious.